Question 15 from your draw sheet. Question 15a. We have got a function which is we have x squared, and then we have plus 1. Then the condition which have been given is x is less than 0. Then we also have another one which is 1 minus x squared. Hey. Then we have been given the condition 0. 0 is less than or equal to x. Then x is less than or equal to what? 1. And then the third one, we have been given that x, where the condition is x, has to be greater than what? Has to be greater than 1. So when it comes for graphing, guys, it's very simple. What we're going to be doing here, we're going to be following the conditions which have been given. That's all. So these are the conditions. Okay, now remember to say when we talk of greater or less than or maybe greater than, we are using what? Open circle. Then when we talk of less than or equal to or greater than or equal to, we are going to be using what? A closed circle. Okay, now these conditions which I've highlighted in lead, they are the ones which are going to be using. So that is the condition which we're going to be using. So the first thing what we're going to do is we're going to write a graph. So we're going to have this, or I can put the graph here. Okay, as long as we have the conditions, that's all. So I'm going to put my graph there. I'm going to have, okay, and then this is what I'm going to have. So now we are going to let's put some point. Let's put, we say this is 1 2, let me use red. We are going to put 1 2 3 4 5 6 7. Same applies to the negative part. Okay, then same applies even there. 1 2, you just put there. You can even put the numbers. Okay, so okay, so now what we're going to do, the first thing is we have this, guys. We have this condition to say the first part of the function, what it means piecewise function. This is the same as we have y is equal to x squared plus 1. Then another one is y is equal to 1 minus x squared. Another one is y is equal to x. Okay, that is what it means. So now we are trying to graph this function. So what we're going to do is we're going to start with the first function. So we're going to have this. We're going to put, this will be x, this will be y. Now our condition here, it is telling us to say the x values which are supposed to be in the first equation, they are supposed to be x is less than 0. So we are going to get the numbers less than 0, but we are going to start from 0, meaning that when it comes for plotting, where it is 0 comma, what we are going to find here is going to be an open circle because 0 is not included. Does that make sense? Let's cooperate. Respond first. Does that make sense? So what we are going to do, we are going to start with the same 0. We are going to put 0 here, and then we are going now to put there to say our equation is x squared plus 1. So where there is x, if I put 0 squared, the value of y is going to be 1. Okay, next, the numbers less than 0, we are going to have negative 1. So if I put negative 1 there, if I put negative 1 squared plus 1, what are we going to get? We're going to get 2. So I'm going to put 2 here. What if I put negative 2? Negative 2 squared is 4. 4 plus 1 is 5. Okay, I can even just put another one, then I say negative 3. If I put negative 3, it's going to be what? 9, right? 9, then 10. So we can say 10. So I got it. You can have 3 points or 4 points. It's okay. Okay, so what we are going to have there is the x, these are the x values which we have, and then these are the y values which we have. So we're going to go to our graph and start now plotting. So we are going to start now counting from there. The x values, we have got 0, so 0 comma 1. So in x values 0, then here we have comma 1 comma 1, so it's going to be this point. Aika. Then negative 1 comma 2. -1 in x direction, then comma 2 is going to be this point. Okay, it's going to be that point. I hope you are following this point here, because we have got 1 here, then -1 comma 2, and then we have got -2 comma 5. -2 is here, although the graph, why can't we just say this? Let me do this. The graph has to be neat. Let's do this. Let's increase a bit here, and then we're going to say we have, yes, yes please, you have got a question? I'm recording. Try to log out, yeah, yes, try to log out and log in again. I'm recording, don't worry. And then what we can see again is that we are going to have what? We are going to have 0 comma 1 is this point, the point which I've just seen here. Then we have 1 comma -1 comma 2 is this point. Then we have -2 comma 5. So this is 3, 4, 5. 5 is there, so it's there. Okay. Then we have got -3 comma what? -3 comma 10. So we can say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is somewhere there. I don't have space, guys, there. Just assume that there is 10 here. It is 10. And then that point is going to be there. Now, when it comes for plotting, we need to understand to say, you can mute your mic. Yes, Chewe. Ask, Chewe. Okay, you don't have a question. So when it comes for plotting, we need to understand to say this first point, it is not included. Therefore, at this point, we're going to put an open circle. So at this point, we're going to put an open circle, not a closed one. Then you just connect the points. Okay, that is the first part. Now the second part, we're going to do the same. So the second part is going to be, we have x, then here we have what? Y. And then the condition is telling us to say the values which are supposed to include, although I've not put one number there, it's supposed to be less than or equal to 1. What it means there, guys, is that the numbers which we are going to put, they're going to be in between 0 and 1. Okay? But both numbers are supposed to be included. Yes. I'm getting you. Yes, I'm recording the class, Winnet. So now, meaning that this condition is telling us to say the numbers in between 0 and 1. We only have two numbers, the same. We have what? We have 0 and what? 1. Okay? So now what we're going to do here, if I put 0 in this equation, what are we going to have? We're going to have 1. If I put 1 in that equation, what are we going to have? We're going to have 0. Meaning that both sides, since it is less than or equal to, we are going to put closed circle. So we're going to go there and 0, 1. Where is 0, 1? So we have got 0 in x, then 1 in y. It's the same point. Okay? So we're going to put there. Then at the same time, we're going to put 1, 0. In x is 1, then 0 is this point. So we can just put, although I know you can't see properly, but that is what is going to happen. We are going to have cross circle, even at this point cross circle. Okay, then you join the two lines. That is the second part. Now the third part, you're going to get the same thing. You have x and then we have y. So our x is telling us to say it's supposed to be greater than 1. So we're going to start from 1, but 1 is going to be an open. So we're going to have 1 and then we can say 2, 3. Let's have just 3 points. So when I put where there's x1, I'm going to have 1 the same one. Here I'm going to have 2 the same one. Here I'm going to have 3. If I put these points there. You can see that? Can you see? So we're going to start now 1 comma 1. Where is 1 comma 1? But we need to understand to say this point here is not supposed to be included. So we're going to put an open circle 1 comma 1. So I've got 1 comma 1 is this point. Okay, then 2 comma 2 is this point. What of 3 comma 3 is also that other point. So and then we need to remember to say we're supposed to put an open circle here, then we connect the points. So that is the graph. Okay, now as you can see, you are going to discover something. This graph from these two guys, it is continuous, but again at this point it is discontinuous. So we're going to show now to say it is continuous at x is equal to 1 or not. Okay, is it okay? Is it okay, guys? Chewe. And then we need also to understand that so now another is saying that is it continuous at c is equal to 0, c is equal to 1, and c is equal to 3. Okay, we are going to test there. We know that for a function to be continuous, these three conditions are supposed to be satisfied. Okay, 1, if f of a exists, then we need to understand again that limit as x approaches a from the right, or we can say from the left side of f of x has to be equal to limit as x approaches a from the right side of f of x. So if these three conditions they are the same, if you find that this guy, again even this condition is the same, then the limit exists. Okay, so I want you to see something. I want to can I go? Is it possible for me to go to the next page? Okay, so now let's start now by saying we want to check if the limit exists or if it is continuous at c is equal to 0. Then we are going to say that f of c, which is going to be, if I put 0 in there, what will be my value there? So I'm going to go back here. Which condition is going to tell us to say x is equal to c? Sorry, x is equal to 0, because we're trying to find the limit at this guy where c is going to be equal to 0. Which one are we going to get? The second one, right? That's where there's 0 less than or equal to what? X, then x what. So what are we going to do now for us to find that one? Let's do fast, guys. You know these things. What are we going to do? Joshua. What are we going to do? Let's do fast. Nanyangwe. Okay, the first, okay, what is the first condition for us to prove that a function is continuous at a certain point? Mhm. Yes, so what are we going to do now? The first condition, that's my question. Supposed to be defined, yes. So what are we going to do now? That's my question. Yes, the equations. Hmm. 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 Okay, so let's now replace where there is we are going to use 0. So it's this function now, 1 minus what? X squared, right? That's what we have agreed. Aika. So if I put 0 there, what are we going to have? We're going, yes, that is what is supposed to be done, eh? Guys, we'll have 1. So if we have 1, we have got one condition. Then another condition is limit as x approaches the same c. Now it's supposed to be from the left side. So c, which is 0 from the left side of f of what? X, has to be equal to, if this condition is going to be satisfied, then we are going to say that this limit is continuous at this point. So now let's see. So this is what we're going to have. So if I put, which one are we going to use now as limit approaches x from, or approaches 0 from the left side? Limit x approaches 0 from the left side. Which one are we going to use? The first one. So we're going to go to the first equation, and then we're going to say the first equation is what? The first equation is what? So it's x squared plus 1. So where there's x, we're going to put now what? 0. Let's put 0. So if we put 0 squared plus 1, what are we going to get? We're going to get 1. Okay, let's try limit as x approaches 0 from the right side of f of x. Which equation are we going to get? Here. Which equation? The second one or the third one? Which equation are we going to get a limit as x approaches 0 from the left, from the right side? The second one? Not the third one is saying that x is greater than 1. But the second equation, if you can check, the second equation is giving us a condition to say it is 0 to 1, meaning that it is 0 to what? To 1. Meaning that if we say 0 plus to the right side, meaning it's this point, this range. So we have been given this guy. So we're going to use the second equation, not the third one, unless we are talking about as x approaches 1 from the left side, or from the right side. That's when we can say we're going to use the third equation. Have you seen? But we are trying to use limit as x approaches 0 from the right side. So we're going to get the third, or the second equation, which is what? X squared minus 1, right? So if we put 0, we're going to get what? Minus 1. It's minus 1 or plus 1? It's 1. Okay, so it's 1 minus 1 minus x squared. So if I put 1 minus 0 squared, I'm going to get 1. So as you can see, so you're going to write now to say, since limit as x approaches 0 from the left side of f of x is equal to limit as x approaches 0 from the right side of f of x. If these two conditions are equal, then you say that this limit exists. The limit exists. So if the limit exists, meaning you can say that f of a or f of c is going to be equal to limit as x approaches 0. Then the limit exists. So it is continuous at c is equal to 1. And this is what I wanted you to see here. If you can check here, guys, the equations which we have used here, we have only used the equation 2 and equation 1. If you can check your graph, equation 2 and this is equation 1, this was equation 2, and it is continuous. This point is going there, then it is meeting this guy, also continuing there. But if we are to use this guy, it's going to be discontinuous, because this guy, it is isolated from those two equations, from the graph. So from the graph, you can tell to say the function is continuous at a certain point. You get it? So what was happening there is this. What was happening there? We had this point, then it was open, but another one was starting from there, but it was closed. That's why it is continuous. Have you seen? But the other one, the other equation which we have not used, starting from there, then it is going there, and for sure it is not touching any of these two, meaning it is not continuous at when we are going to use this equation. Okay, which another question should we answer? Yes, go ahead. Yes. They are there. Just a minute there. Let me go back to the draw sheet. They are there. You mean the one which was saying limit as x approaches 3, right? Oh, as c is equal to 1, 2, 3. So we get the one for 3, huh? Yes, we are supposed to use all of them. Is it continuous at c is equal to 0? Yes, it is continuous. Is it continuous at c is equal to 1? We want to test now, but we're not going to do that because of time. Do you want us to do? Yes, yes. Y- yes, exactly. Sure. So you can now solve as c at point c is equal to 1 and 3, right? We can move. Which one from the draw sheet? Question 16, pick one or pick two. Let's do first. Question 16, pick two. Okay, let me say question 16, pick 4. Because if you pick 2, there are a lot there which are difficult. We should do D and what? Okay, so D is saying we try E, then we are remaining with 2. Which ones now? No, there is H there. There is H, I, J, K, I. Or L. Limit as x approaches 2. Then you have the root of x squared minus 4 open brackets x minus 3x plus 2. Okay, so the first thing there, if I try to put 2 here, you are going to discover that we are going to get 0 over 0, and we don't want to get this condition. This is undefined. Okay, so what we are going to do there is we are going to factorize. So what we are going to have down there, this guy is factorizable, this down part. Then this guy here, which is x minus 4, it is the same as we can say x squared minus 2 squared, which is going to be x minus 2 then x plus 2. This is the same as this. I hope no one is behind there. Confirm fast. Nanyangwe. Yes. Is it okay? The top part I'm going to replace with x minus 2 then x plus 2. It's okay, right? Then the bottom part here we have got 2 here, we have got this one. We are going to find two factors. When we do plus or minus, we are supposed to get negative 3. If I do times those two numbers, I'm supposed to get 2. So if guys I do negative 2 and negative 1, if I do plus these two guys, I'm going to get negative 3. If I do times, I'm going to get positive 2. Therefore, these are the numbers which I'm going to use, the factors. And remember, I said that if the coefficient of this guy here is 1, don't even waste time. Just get the same ones, meaning if you factorize this one, you're going to get x minus 2 as well as x plus minus 1. Don't even waste time. Just replace them there, because there is no any mark for you factorizing this guy. Okay, so we're going to have limit as x approaches 2. So in there we're going to have x minus 2 then x plus 2. Then down there we're going to have x minus 2, and then we're going to have x minus 1. So at this point we can cancel this guy. Then we're going to remain with limit as x approaches 2. Then we're going to have this. We have remained with x plus 2 then x minus 1. Let's plug in the values. Now, I said that when you want to plug in the value of x, that's when you stop now introducing limit. Please take note. You only stop introducing this one when you want to plug in the value of that x. Okay? So at this point, since we want to plug in, then we are going to say equal to the square root. Since I want to plug in the values, I'm going to say 2 plus 2 is going divided by what? 2 minus 1, which is going to be equal to what? 4 divided by 1, which is going to be equal to 4, which is going to be equal to 2. Have you seen? So you continue bringing in limit as x approaches that number until you reach at the part where you are going to plug in the value of that x. That's when you stop now introducing the limit. Is that okay? Is that okay? Okay. Question E. Question E we have, I think we did this one with me, remember? 1 minus x squared. What we said, guys, was if you have limit as x approaches 0, we have limit as x approaches 0, then you have 1 over x. This one is going to be undefined. This limit doesn't exist, because what we are going to do here is we are going to test both sides. We're going to test from the left as well as what light. So we're going to say that limit as x approaches 0 from the left side. So from the left side, we're going to get a number which is going to be less than 0, which is just closer to 0 but not necessarily 0. You get it? So if I get, we have this. Which number do you think we are going to get here? A number which is closer to 0 but not 0. It is just approaching 0. It's more like you have this. This is the graph. Now it is just approaching 0 but it's not necessarily 0. Which number can we get? You can get 0.01, right? So if I get 0.01, you are going to discover to say this one is going to give us what? 100. If I do 1 over, it's going to give us 100, which is positive 100. Now, we agreed, you and I, that the limit is supposed to exist if the limit as x approaches that number from the left side as well as from the right side is supposed to be equal, meaning the limit exists. So now let's try to say, although this one was supposed to be, since it is left, meaning it's supposed to be negative 0.00, therefore we are supposed to get this one as negative. I hope you have gotten the logic there. The limit as x approaches 0 from the right side, we're going to get the same. Okay, we're going to get a number which is closer to 0 but not necessarily 0. So we can say positive 0.01, which is going to be positive 100. So is positive 100 and negative 100 the same? They are not the same, meaning this limit doesn't exist. You are supposed to show it like this for you to prove, to say this limit doesn't exist. So if that limit doesn't exist, I'm just giving you an example. So what we are going to do, guys, from here, we are going to test this limit both sides, from left as well as right. So we are supposed to get the same answer. If we are going to get the same answer, then the limit exists. So let's start. We are going to start to say limit as x approaches 0 from the left side. So we're going to have 1 over x and then minus 1 over x squared. Now we're going to be putting the numbers which are closer to what? Closer to 0 but left side. It's more like we have this. This is the number, we have 0 this point. So now from the left side is this side. So you can put any number which is closer to 0. You can just say negative 0.0, just 0.1, just like that. Okay, for you not to be confused. So what we're going to do there, we're going to say 1 over negative 0.001 minus 1 over negative 0.001. We have said it's going to be, but for you not to be confused, just put 0. Just say this, just put simple number, or negative 0.1, then even here minus 1 over 0, negative 0.1. Now as you square it. So what are we going to get here if I do 1 over negative 0. This part, guys, what are we going to get? It's going to be negative what? Negative 10, right? Negative 10. Now negative 10, if I square this guy, I'm going to get positive, right? If you so you're going to have, if negative 0.1 times itself, you square it, what are you going to have? Negative is going to be 0.01, which is going to be minus 100. Aika. So now this guy is going to give us negative 110. So that is the answer for the left side. Let's check if we're going to get the same for the right side. Have you seen? So we're going to prove again. We're going to say limit as x approaches. So in short, this limit as x approaches this one, we're going to get positive infinity. What is happening there is as the number, if we can put this one, we are going to get a thousand, maybe a 10,000. So you can say that this one is going to give us what? Negative what? Infinity. Then now, limit as x approaches positive from the right side, what are we going to have? So if we put positive there, 0.1, then minus 1 over 0.1 squared. Are we going to get negative or positive? It's a positive number. Does this limit exist? Does this limit exist? It doesn't exist. If it was to exist, you are supposed to get this limit doesn't exist. But if you have this, if you have 1 over x squared, just like this, the limit is going to exist. So the only part which has made this limit not to exist is just this part, because we know that 1 over x, the limit doesn't exist. But if you have got, if it was just negative, if it was just like this limit would have exist, would have gotten negative infinity both side, or positive infinity. Have you seen ka? So as limit approaches x, or as limit approaches 0, just test both sides from negative as well as what? Positive. And in most cases the answer is either positive infinity or negative infinity or positive infinity, as if x approaches 0. Most of the times, not always, but most of the times. Okay, another one. We have said 4 from this point, so which one and which one? Let's do first time, guys. J. Okay, J is saying limit as x approaches 0, then we have what? The root of x squared plus 4, and then minus what? Minus 2. Then we have over x squared. Genuinely speaking, what is happening here is this part which is in the square root, since it is squared already there, even if I put negative or positive any number, we are going to get a positive number. You agree with me? You agree with me, right? Okay. If you want, okay, so we're going to test both sides, because if I put 0 there, it's going to be the same thing. So I'm going to say limit as x approaches 0 from the left side. So which number do you think? We are going to use the same one, 0.1, because it's the one which is going to give us. So if I say 0.1, now left side is supposed to be negative, sorry. So it's going to be negative 0.1, I square it plus 4, then minus 2. Don't even bother for you to find the answer, because the answer is going to be positive infinity or negative infinity. You get my point, right? So here if I put negative 0.1, what you need to understand is this one is going to, we are going to square it. Okay, so if this one is squared, this part here we're going to get a positive number. But if we get a positive minus, but this number is going to be very, very small. We have got it's going to be 0.01 plus 4, which is going to be 4.01, right? I'm asking you guys. Now the square root of this number is going to be somewhere there 2 point something, which means that on top there we're going to get a positive. So if on top there we're going to get a positive, okay? So what I want you to know is just this. It's just this, guys. If I square this bottom part, it's going to be positive. Now when I divide that one, maybe you're going to get about somewhere there 1 over maybe 0.001. So if I put there, it's going to give me still positive infinity. Still, even if I put positive number, it's going to give me still positive, meaning this limit exists. So it's just a matter of you are going to test both sides, test left as well as right. If you're getting both positive or negative, then the limit exists. So you can finish from here. Just put small numbers. Just put 0.1. You square it is 0.01. If here you are going to have 0.01 plus 4, which is going to be 4.01. Now the square root of this one, you know that is going to be a positive. So you plug in there. Yeah, we're going to get positive infinity. So this one wasn't hard, unless you tell me question, maybe question K. Okay, which one should we get? K, we have got two there. We have got two things. We have got K and L. Which one should we solve? We solve L, but you know how to solve K? You know how to solve K? I want everyone to respond. You don't know how to solve K? So we have this. We have x approaches 0. But now we need to understand that we have 2x and then plus, this is squared, and then plus x. Then we have x. Now x is in modulus. But we need to understand that modulus means that it can either be negative or what? Or positive, right? Hey. So I'm going to teach you, let me just teach you one method. So what is going to happen there, if we want, we can do this. We can write two things. We're going to have limit as x approaches 0 from the left side. Now, from the left side, meaning this x, if we open the brackets, or maybe, yeah, from the left side, then I have got 2x squared plus x. You remember when you are doing modulus function where you have this, and then we were getting this one as plus or minus. I want you to relate. You remember, right? You remember? So even here, this is what we're going to get to have. We're going to have this one. We're going to have, let's put now negative. We're going to have two things. Okay? So now let's plug in now. The number which is going to be this side less than, it's the same thing, guys. It doesn't change. Okay, so this part is not, it's not going to affect anything, the top part. The only thing which we are dealing here, okay, we can just say 2. Let's replace with 0 point or negative, sorry, negative 0.01. Let's just put negative 0.1. Yes. It's the same. I wanted to teach you two methods. Yeah, I wanted to teach you two methods. So I don't know if you are comfortable with the. Should I teach you shortcut? I'm asking. I finished this one. Maybe you don't want it. Yes, yes. Yes, go ahead. Mm-hmm. Mm-hmm. It's positive. Oh, you can okay, just a minute. You can you can come again. I've not gotten your question. You are saying? Hmm. Yes. Okay. Um, that point of factoring out the x, I don't think it can work because do you know that when we say modulus, we mean two things. So if we factor out x, maybe this x was negative inside, but we really don't know. Why? So I want you to get this point. We really don't know, guys, if this x, if we say x, open brackets, then we say 2x plus 1, okay, and then we have this x. So if we cancel this x, we really don't know that if this x was what if this x was negative? Don't you think that then we have left out negative outside? Why son? But now that method yes can only work. Mhm. Yes, come again. Mhm, 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 mhm. Okay, yeah, yeah, yeah. Oh, yeah, yeah. That is what. Okay, now I didn't get that point. Yeah, that one is correct. Because if we are going to say limit as x approaches 0 from the left side, then this one we're going to get now as negative. We say this, then we put negative x, and then we factor out in x, right? Then we're going to have limit. Don't forget to bring in limit here, guys. So it's going to be x, open brackets, 2x plus 1, and then divided by what? X, negative x. So this one will go there. Then we're going to have limit as x approaches. So if the answer is going to be the same, then the limit x is going to exist. So then we're going to have it's the same as we can say negative 2x then minus 1, right? It's the same, right? Then if we divide there, what we're going to have, so we're going to get a number which is going to be closer, not really 0, but anyway, at this case, since it can't be undefined, we just plug in 0. So we're going to say negative 2, 0, negative 1. I said you only move as x limit as x approaches something when you want to plug in the values, right? So it's going to be this. You can plug in direct 0 when you see that it can't be undefined, right? Remember? So we're going to have this. Then we're going to have negative 1. Now, let's see if we do the same to the light side, if we're going to get negative 1. If you're going to get negative 1, the limit exists. If you're not going to get negative 1, the limit doesn't exist. So let's start now. Limit as x approaches 0 from the light side, meaning now here we're going to put a positive 1. Sorry. This one is going to be now, we have 2x squared plus 1. Then instead of putting negative here, we're going to put x. Just x as a positive, because here it was left side we included negative. So here it's going to be like that. Okay, let's factor out x. So it's going to be limit as x approaches 0 from the left side, or from the right side, sorry. Then x, 2x plus 1. This was x, plus 1, then divided by x. X and x will go. Let's plug in the values. If you are to plug in the values, you are going to agree with me to say it's going to be positive 1, right? Meaning that this limit doesn't exist because these two guys are different. So this is what you say. Since limit, so you're going to say since limit as x approaches 0 from the left side, of f of x is not equal to limit as x approaches 0 from the left side of f of x, then the limit doesn't exist. That's the last statement. Have you seen come? Time, guys. And then I don't know. Okay, this is the simplest way. I wanted to teach you two methods, but I feel like that is the simplest one. Or maybe I can just write it, then I post it in the group, right? The second one. Guys, why this one? Okay. So now, where we go to which question? L. Yes, it's the same. Since it is modulus, it's just the same thing. Mevin, are you here? I want this guy to get this question. Vaenda foot. Anyway, yeah, it's the same method. Yes, yes. It's the same. Yeah, it's the same thing. Okay, you can try it out, then you can post in the group. It's the same thing. You're going to get the same thing. Yes. Uh, yes, we can do the last one. You can choose one from 17 and 18. But 17, we have already done 17, so there's no need of us. You can solve question 17b, right? Just follow the conditions. For example, that one is saying that x is not equal to 2, don't plug in 2. Those are simple things. The continuation, define as f of a c so that the function is continuous at x is not equal to 1, c is equal to 1. It's the same thing, guys. Okay, Kai, again, we know that it's going to be a quiz, and we need to understand that you're going to have, with the questions from binomial inequalities, you're going to have 3 questions. So maybe question 1 is going to be for inequalities, question 2 binomial, question 3 limits or calculus, which is going to be simple for you. So we can end here. Then we have not I don't know if you know, if they ask you limit as x approaches infinity. Do you have any question which is talking about as x approaches infinity? I think we have not solved such question. It's h, h and I. But you remember what I said when it counts for limit as x approaches infinity. I want us to have a break for about 30 minutes. Then we start those other things. Yes, Mama, ask. You have got a question?